Imagine this scene, a cosmic casino where the rules of the game were written at the very moment of creation. Every dice roll, every spin of the roulette wheel, every card dealt follows immutable mathematical laws. Now imagine that after billions of years of play, you finally get to observe this casino and discover something profoundly disturbing. The dice are loaded. The roulette seems to always land on the same number. The cards arrange themselves in perfect sequences. And most extraordinarily, this cosmic loading is the only reason you exist to observe it. This isn't poetic metaphor. It's the fundamental reality of our universe, a mystery that challenges everything we think we know about probability and existence. Welcome to the greatest puzzle of modern science.
Let's put our cards on the table, or rather the dice on the cosmic board. When physicists began calculating the basic probabilities for the existence of a universe capable of sustaining life, the numbers that emerged were so absurdly small they defy any rational notion of probability. Consider the gravitational constant. If it were just 0.0000001% stronger, the universe would have collapsed upon itself before the first stars even ignited. Slightly weaker, and all matter would spread so rapidly that galaxies would never form. Now multiply this improbability by more than 20 fundamental constants, each precisely tuned, each perfectly synchronized, and you begin to understand the magnitude of this puzzle. Biochemist Michael Denton calculated that the probability of all these constants being in the ranges necessary for life by mere chance is comparable to the probability of a hurricane passing through a junkyard and accidentally assembling a fully functional Boeing 747. And this is just the beginning of our story.
This is where most people interrupt with the seemingly obvious answer. Of course the universe seems perfect for us. If it weren't, we wouldn't be here to observe it. This idea, known as the weak anthropic principle, sounds elegantly logical at first glance. It's like a fish saying, "Of course water is perfect for me. If it weren't, I wouldn't be here swimming in it." But this answer, while technically correct, is profoundly unsatisfactory. It's like finding a perfectly functional Swiss watch on the beach and concluding that ocean waves simply assembled it by chance over millions of years. Physicist John Wheeler offers a more powerful analogy. Imagine you're in a room with 100 guns pointed at your head. Each has a loaded cartridge, but when all triggers are pulled, all 100 guns simultaneously fail. You might say, well, if any had worked, I wouldn't be here to wonder why they failed. But this doesn't answer the truly important question. Why did they all fail? The anthropic principle explains why we can ask the question, but doesn't answer why the conditions for asking it exist in the first place. Let's examine this cosmic loading more closely. Begin with the strong nuclear force, the glue holding atomic nuclei together. If this force were just 2% stronger, all hydrogen in the early universe would have fused into helium, and stars like our sun and the complex chemistry needed for life would never have existed. 2% weaker, and not even deuterium would form, completely preventing stellar nucleosynthesis. We're talking about precision comparable to an archer hitting a 1-centimeter target from a distance of 1,000 light-years. The cosmological constant, controlling the universe's accelerated expansion, presents an even more impressive tuning. Its observed value is 120 orders of magnitude smaller than what quantum field theory predicts. This is equivalent to hitting a proton-sized target in an area the size of the entire observable universe. It's the most inaccurate theoretical prediction ever made in science history. And yet this colossal error is exactly what allows galaxies, stars, and planets to form. The electromagnetic force offers another extraordinary example. When a carbon-12 nucleus forms in stellar cores,
It depends on a perfectly tuned resonance state. Physicist Fred Hoyle predicted this resonance specifically because, without it, the universe wouldn't have enough carbon for life as we know it. He essentially argued carbon exists, therefore this resonance must exist, and he was absolutely correct. It's as if the laws of physics were pre-programmed to produce life's ingredients. Finally, consider the relationship between fundamental forces. Gravitational force is approximately 10 to the 36th times weaker than electromagnetic force. If this ratio were slightly different, stars like our Sun would burn their fuel in millions rather than billions of years, insufficient time for complex life to evolve. Each of these coincidences alone would be remarkable. Together, they form a pattern demanding explanation. So what's really happening? The scientific community divides into three main camps, each more radical than the last. The first camp argues we're facing the greatest cosmic coincidence of all time, that by pure statistical accident, our particular universe ended up with the right constants. This position, while logically possible, requires accepting such colossal improbability that many scientists consider it philosophically unsustainable. The second camp proposes a multiverse existence, a vast ocean of parallel universes, each with its own physical constants and natural laws. In this scenario, most universes are sterile and empty, but occasionally, by pure statistical luck, a universe like ours emerges with perfect conditions for life. We simply have the luck to inhabit this rare exception. It's an elegant idea, but presents its own problem. If other universes are, by definition, unobservable, how can we scientifically test this hypothesis? The third camp is the most controversial and philosophically challenging. The possibility that fundamental constants aren't accidental, but rather necessary consequences of a deeper physical theory we haven't yet discovered. Just as pi necessarily emerges from Euclidean geometry, perhaps the constants we observe are the only possible ones in a self-consistent universe. This view suggests that, deep down, life isn't a happy accident, but an inevitable consequence of reality's deep laws. But the fine-tuning of fundamental constants is only this story's first act. Even with perfect conditions, life's emergence from inorganic matter presents its own set of statistically improbable loadings. Life's origin requires complex organic molecules to self-organize in specific ways, a process that, in laboratory, demands constant, intelligent intervention. Yet on early Earth, this happened relatively quickly after the planet cooled. More impressive still is evolutionary convergence. Eyes evolved independently at least 40 times throughout life's history. Photosynthesis emerged multiple times. Complex forms like brains, societies, and language appeared in completely separate lineages. This suggests that, given the right conditions, life not only emerges, but seems channeled towards certain solutions, as if following a cosmic script written in physics and chemistry's very laws. Biologist Simon Conway Morris goes further, arguing that on any Earth-like planet, evolution would likely produce creatures remarkably similar to what we see here, perhaps even humanoids. This idea of convergent evolution on cosmic scale suggests that life, and possibly even consciousness, may be far more common in the universe than we imagine, provided basic conditions are present. Here, we reach the most radical idea of all, one uniting quantum physics with philosophy of mind. In the Copenhagen interpretation of quantum mechanics, the act of observation seems to play a fundamental role in determining reality. Particles exist in superposition states until measured, when they collapse into defined states. John Wheeler took this idea to cosmological extreme with his participatory universe hypothesis. Wheeler proposed that the universe only gains defined existence through observation by conscious beings. In his view, we aren't mere passive spectators of a pre-existing universe, but active participants in its continuous creation. The past isn't fixed, but determined retroactively by observations made in the present. This extraordinary idea suggests consciousness isn't an accidental byproduct of the universe, but rather a fundamental component of its structure. Theoretical physicist John Archibald Wheeler summarized this view with his famous phrase, "it from bit." Physical matter, it, fundamentally emerges from information, bit. In this perspective, the universe resembles a great thought more than a great machine. And if this view is correct, the loading we detect in fundamental constants may be less about the universe's properties and more about reality and consciousness's deeply intertwined nature.
So, where does this leave us? We return to our cosmic casino, but now with much richer understanding of the mystery. The evidence is overwhelming. Nature's fundamental constants seem finely tuned for life in ways defying simple explanations by chance. Whether through multiverse, deeper physical theory, or fundamental connection between consciousness and cosmos, one thing seems clear. Our existence isn't a mere statistical accident. This doesn't prove any specific religious tradition, but certainly suggests life and consciousness have deeper cosmic meaning than pure materialism could suggest. In a universe where probabilities were astronomically against us, we, and possibly countless other conscious life forms, emerged not despite cosmic laws, but because of them. The loading we detected may be the most important clue we've ever found about reality's true nature. And this leads to an extraordinary conclusion. When studying the universe, we're not just exploring an external realm of galaxies and particles. We're, in a very real sense, exploring our own nature's depths and our place in the cosmic fabric. This investigation is far from over. Each year, new data from telescopes, particle physics experiments, and biological research add pieces to this cosmic puzzle. The fundamental question, are we alone in the universe, or is life a fundamental feature of reality, may be about to be answered within our lifetimes. If you want to follow this discovery journey with us, consider subscribing to the channel. We weekly explore science, philosophy, and cosmology's frontiers, always with factual rigor and depth. Your subscription helps this project grow and enables us to investigate even deeper questions. Now we want to hear from you. Faced with this evidence, which explanation seems most plausible for the universe's fine-tuning? Is it the multiverse, a deeper physical theory, or something even more radical? Your ideas contribute to this cosmic conversation. Share in the comments below what are your thoughts on this fundamental mystery. If this video expands your perspective on the cosmos, comment on your thoughts and leave a like to help us reach other cosmically curious people. Until next time, keep looking at the stars, but remember that the greatest mystery may not lie out there, but in the very possibility we're here to question.